So the first thing we're going to notice is that in the general form. And if we look back at our diagram, what can the general form tell us? Well, the general form, basically, it can tell us the a value, so we should know if this opens up or down, and whether it's narrower or wider than a regular x-squared graph. And we can also find the y-intercept easily. So the only thing that we can really find from our general form is we know that the y-intercept, if we plug in 0 for x, we get 0, -14. That's relatively easy. Okay? We see that the a value is -2, so we know that it opens down and would be narrower than y equals x squared, because the 2 stretches it vertically, making the parabola more narrow than a regular x squared graph. But those are the only things that we can figure out from general form. So then, in order to graph this, we have to decide what else do we want. Now, one of the things that we will always need when we graph is our vertex. So if we're wanting to graph and we're wanting to find our vertex, okay, our vertex is right down here in purple on our diagram. To find it, we can either get there via the standard form, and that would be the easiest, that's why it's highlighted in yellow. But you could also get there sort of a long way through the factored form, okay? So what we could do here is we could look at our question, and we could say, can we put it in factored form? Could we put it in standard vertex form? And I'll color code these so that we can see. If I wanted to factor, I would factor out my -2, leaving me with x squared minus 5x plus 7. And then I would notice that this cannot be factored any further. So the factored form kind of doesn't give us any information this time. Because if we look at our diagram and we say, if I go to the factored form, I could find my y-intercept, but I already found that through my general form. I could find my a value, but I already knew that one through my general form. And then I could find my x-intercepts, but only if I could factor. So now the factored form isn't going to help us with the graphing at all in this question. So we for sure are going to need our standard form. Our standard form, we get that by changing to standard form, and this is a very important technique to know. So we need to, first of all, I'm going to write out from our formula sheet, because this can help you remember the technique that you need to do to change it to standard form. So on our formula sheet, that's what standard form looks like. It has the a value factored out. It has a number at the end. So as a starting point, we factor out our a value, -2. That would leave me with x squared minus 5x. And I'm going to leave the -14 on the outside because I know that I need a number on the outside. And this is where, in the changing to standard form, very similar to completing the square in solving equations, but a little bit different technique, we draw a space inside the brackets because we need this to equal something squared. The hint is the -5. If you have a -5 there, then inside will be -5/2. Just telling me I'm getting an error somewhere? Of course it's getting an error. Maybe it's been working. Who knows? So we have a -2, x minus 5/2 squared. If we had the -5/2 squared, that would be a 25 over 4 that would get added inside the brackets. And we get that number by squaring 5 over 2. However, now our brain normally says if I add 25 over 4 here, in the other blue space, I should subtract 25 over 4, because if you add something to one side of the equation, you need to subtract it at the same time to make it balance out or to compensate. But we haven't actually added 25 over 4, because by putting the 25 over 4 in that spot, it gets multiplied by that negative 2. So actually, I have subtracted negative 50 over 4, because when I multiply that by negative 2, I would get negative 50 over 4. So in order to do the opposite of negative 50 over 4, over here I have to add. And is it all right if I change the 50 over 4 to 25 over 2? So my final number, I'm going to change my minus 14 to 28 over 2. I'm adding 25 over 2. And so, simplifying this equation, I now know my vertex is at 5 over 2, comma, negative 3 over 2. I know that my axis of symmetry is at x equals 5 over 2. I can start drawing my graph. And on your graph, you will need to label your vertex. So I'm going to go 1, 2, 3. And go over 2.5 and down 1.5 and label that point. I know that it goes over 1, down 2, over 1, down 2. I also know, okay, in this situation, I would probably go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I would also label my y-intercept, and then I have enough information to draw my graph. You need to have at least 2 points labeled on a parabola. The vertex is very important. The second point gives you how narrow or how wide it is. So the 0, negative 14 is important for that reason. Okay? If I went over 1, down 2, I would get 7 over 2, comma, negative 7 over 2. It's possible to do, but the fractions in this one make it not as nice to write points. So that's where the y-intercept is very helpful. We can label our axes of symmetry with a dotted line. I prefer to use a red pen for that. And we can label it as x equals 5 over 2. It's what splits your parabola equally in half. If we look, are there other things that we could label? Well, there are no x-intercepts because it's below and going down. So it kind of made sense in the factored form that you never found any. Okay? And one of the things that, if you want to go back to your chart here and double check, you can see the other characteristics are domain and range, but those are describing characteristics, not something we label on a graph. And we didn't have any x-intercepts. So we have labeled this completely. One of the things that I talked about in this question Now, with the factored form, if you're unsure, if your mental math skills are not helping you find out if something can be factored or not, you can use the discriminant to find out if something can be factored. So the discriminant is the b squared minus 4ac. If I scroll up just for a second here, we had x squared minus 5x, right? This, we are wondering, could this be factored? If I plug that into my discriminant, negative 5 squared is 25 minus 4 times a, which is 1, times c, which is 7, is equal to negative 3. Okay? This negative 3 tells us that there would be 0 roots, no solutions. The only way you can factor, maybe I'll put it underneath here, is if your discriminant is a perfect square, like the square root of 16, square root of 25, square root of 36, square root of 49. If it's a perfect square, you'll be able to factor it. If it's not, if it was square root of 17, square root of 21, square root of 3, or square root of any negative number, then you know it can't be factored. So that was part A. We did that one before earlier. Now we can look at doing part B. We'll do that on another page as soon as the button I pushed worked. Or maybe we'll use a different button. So the question is, y equals 4x squared plus 12x plus 5. 4x squared plus 12x plus 5. This is the general form. What can we find from our general form? Really easily, we can plug in 0 for x and get our y-intercept. We also know that it opens up. And would be narrower than y equals x squared because the a value is 4. We want to graph this. So the things that would help us graph this are the standard form or the factored form. I hope you start to realize that the standard form always works. The factored form in our last example didn't work at all. So I would probably start with the standard form. Okay, again, I'll write it out. This is what the standard form looks like. That's your hint. So we need to factor out our a value, which is the 4, leaving me with x squared plus 3x. Leave a space. I have a plus 5, but I'm going to leave another space over there to compensate. And then the 3 is our hint. If we have a plus 3 there, we would have plus 3 over 2. If we have plus 3 over 2, we would add 9 over 4 inside. That 9 over 4 gets multiplied by that 4. So we've actually added 9. So here I would need to subtract 9 to compensate. 5 minus 9 gives me minus 4. So changing to standard form gives me a vertex of negative 3 over 2, comma, negative 4. It also tells me my axis of symmetry is at x equals negative 3 over 2. So if I actually label this, 1, 2, 3, what do I know so far? I know that my vertex is at negative 3 over 2, which is negative 1.5. I know that point already. I know that my y-intercept is at 0, 5. And technically, this is enough information to do the graph perfectly. Okay? Some other things you could use, because the a value is 4, you could go over 1, up 4, over 1, up 4. And if you go over 1, up 4, we get lucky that that works out perfectly to be our x-intercepts. Negative 0.5, comma 0, and negative 2.5, comma 0 are our x-intercepts. We can draw our axis of symmetry, take out a red pen, write down the middle, label it x equals negative 3 over 2. So our standard form in this question not only found the rest of the things, but we got lucky that we also found the x-intercepts. But we're going to go back, now that we've done the standard form, we're going to go back and find the factored form. We cannot factor out our a value because there's not a 4 common in all 3. So we just write our brackets. If it could be factored, okay, and by the way, if I look at b squared minus 4ac, the discriminant in this one, I would get 144 minus 80, which is 64. And 64 is a perfect square, 8 times 8. So my discriminant tells me it can be factored. So now, how do I go about factoring this one? Because it's a little bit more difficult. I would actually start with the last ones. Because it's a 5, you only have one option, 5 and 1. Then I would look, should I use 4 and 1, 1 and 4, or 2 and 2? I need to get 12. Doesn't take too long with mental math to see that if I do 2 and 2, my inside is 10x, my outside is 2x. 10x plus 2x will give me 12x. And there we have our factored form. So that would tell us our x, if you want to find an x-intercept, you plug in 0 for y. And since it's factored, this is chapter 3. Chapter 3 we learned is you could factor it. You get x equals negative 5 over 2 and x equals negative 1 over 2. And if we scroll down, we can see that we already have those points labeled on our graph. But the only thing the factored form tells us directly is our x-intercepts. Then you could have found the average of your x-intercepts to find your axis of symmetry. And if you had your axis of symmetry, you could plug that number in to find your vertex. But the standard form finds the vertex easier. Okay, try questions 6 and 7. Start those right now.